Hello, everyone. I'm honored to have the opportunity to present our project at this conference. So first of all, thank you. My colleague Anna and I have been working on a customized implementation of online search quality evaluation using Kibana, which I will discuss and elaborate on in this presentation. Just a quick introduction about myself. My name is Ilaria. I'm Italian, but I live abroad in the Middle East. I earned a master in data science in 2020 in Rome, and soon after joined SIS team, where I've been working as R&D and machine learning software engineer. I have passion for data mining and machine learning, deep learning techniques, and I mainly deal with their integration with search engine and information retrieval system. I'm a sports lover and an ex-professional basketball player. Just a bit about our company, SIS, which means Search Services. It was founded in 2016. It is headquartered in London, but all the employees are distributed worldwide. We are information retrieval experts and open source enthusiasts. We work with Apache Lucene, Solar, and Elasticsearch mostly. We are researchers, and we actively contribute back to the community in open source project. And what we mostly work on: neural search, learning to rank, document similarity, search quality evaluation, and relevance tuning. The talk is divided mainly in three parts. So first of all, we will briefly introduce what is online search quality evaluation, and we give you an overview of A/B testing. We then dive into our Kibana implementation and the reason behind it. We will finally explore some Kibana tools through practical example to show you how to create visualization and dashboard to compare different ranking models. So let's get started with online search quality evaluation. Online evaluation is one of the most common approaches to measure the effectiveness of an information retrieval system. It remains the optimal way to prove how your model performs in a real-world scenario, and it can give you the necessary information to evaluate, improve, and better understand the behavior of your model. Both offline and online evaluation are vital for a business. In fact, one does not exclude the other, and you should always monitor both the aspects. Offline evaluation is an evaluation method that can help you to find the most promising model before deployment. It has the advantages to find anomalies in data. You can set up a control environment that is not influenced by the external world, and you can check the model performance without impacting the production system. You can rely on offline evaluation, but you can't really be sure what the impact will be on the website, because the final word on the success or failure of a release version is decided online, where you can measure live the vital metrics for a business with real users, and you can identify anomalies for unexpected queries, unexpected user behaviors. Of course, it is more expensive in terms of time and cost compared to offline evaluation. But how to compare different models online with real users? In the industry, there are two types of online testing that are widely spread: A/B testing and interleaving. In this talk, we will only focus on the A/B testing approach because it's the one we use. As you can see from the picture, in this test, two models are compared, and the audience is split into two groups, generally 50-50. This test is easy to implement, but it requires a high amount of traffic and time. And one important aspect to consider is to remove or reduce as much as possible the noise. What I mean is that you have to take into account all the interactions that come from the result page you are comparing online, and not consider those from different pages or different sources. There are various metrics that you can calculate online. Each of these metrics model a certain aspect of search quality. The most common one, I think one of the most important, is the click-through rate, calculated by dividing the number of clicks on a product, on a document, by the total views it received. If you are in an e-commerce scenario, it is important to also track sales and revenues, as an high click-through rate doesn't necessarily mean your search engine is performing well, because if you don't see any sales, your search engine maybe is not performing as you expect, Other aspect can be the monitoring of time spent by a user on a search result page after clicking on a result from a query. If we spend a lot of time on it, it could be a good signal for the real relevance of the document. And there are also other aspects that maybe you would like to monitor online, like the amount of query reformulation, so how many times the user rewrite the same query, and the bounce rate refers to the percentage of users who leave the search result page after only visiting one page. Our recommendation is that you should always start from signal as close as possible to the search engine, and then, of course, monitor all of them step by step. Now, let's dive into our Kibana implementation. What are the reasons behind it? Nowadays, the available online evaluation tool presents some limitations in terms of data and metrics to use. It's difficult to find and, of course, use the same metrics that we use to optimize the model. And it's not easy and immediate to remove external factor or, for example, corrupt interactions. That's why we decided to implement this online evaluation through the use of Kibana. This is a tool that provides the search and visualization capability for index data in Elasticsearch. Here is the pipeline for implementing this online search quality evaluation. So you should create, or maybe you already have, an active Elasticsearch instance associated with Kibana. You should create an index with explicit mapping if possible. You should, of course, set up and start your A/B testing. You should index the user interaction data you are collecting, which you will then need to evaluate the performance of the model on the chosen metrics. And then you have to create the data view, because Kibana requires it to access the Elasticsearch data that you want to explore. And finally, you can leverage Kibana tools to create visualization and dashboard and compare different models. In this example implementation, we assume to be in a book e-commerce scenario where we daily collect user interactions to understand how users are interacting with the search engine. So we index these interactions, and the Elasticsearch index contains this document field. Book ID to specify specific product, specific document. Test group to identify the model that was assigned to a user group for the A/B testing. Then we have the query ID. In our case, was the category. Timestamp is useful if you want to do a temporal analysis. Interaction type to understand what kind of interactions took place. And we also had 4 single fields about interactions that are just supporting calculation to create some visualization. So impression, click, add to cart, and sales. These are Boolean fields, so they have 0 or 1 depending on the interaction type. We have the query result count. Is useful if you want to do an analysis based on the number of search results returned for a given query. And finally, the user device. You can, of course, consider and add additional features that you think would be useful for your case and domain. So now let's dive into the most interesting part. Well, we will only focus on how to create visualization and dashboard. In Kibana, there are multiple editors available for creating panels of your data. The first panel type we present is the data table using the aggregation-based editor. The data table is a type of visualization that is used to display raw data in a tabular format with various types of aggregation and sub-aggregation, and used to calculate different predefined metrics. So we use this panel to evaluate the distribution of data by model and by day. So you can split row thanks to terms aggregation, in this case on test group field, so using the model name. And you can also create sub-aggregation. So in this case, we again split the row using the timestamp, and in particular looking at different days. You can calculate predefined metrics and represent them as table columns. You can easily see that the total number of impression, that is a sum aggregation of field impression, total number of click, total number of add to cart we have collected for each day and for each model. In this case, we filter for model A, but if you want to see both models, you can remove the filter. This table is useful for understanding if the testing process is distributing the models equally or in the desired percentage, and so discover any sort of imbalances. The second panel type used is in the tabular format as well, but it is obtained using another editor, time series visual builder. The difference with the previous one is that it is optimized for a specific use case, and you can also calculate custom metrics, like in this case, click-to rate and add-to-cart rate, which require a specific formula to be implemented. So we use this panel for the general evaluation of the model. With this table, we represent the performance of two models, model A and model B. Table rows were obtained group by test group field. So again, thanks to temps aggregation. Then we created several columns representing the most important metric we would have liked to look at. And we are able to obtain the first three columns, the first three metrics, also with the other table panel seen before. But since we are in an e-commerce scenario, we want to calculate also click-to rate and add-to-cart rate, because they are also the ones we usually use for the optimization of the model. So with this panel, thanks to the bucket script aggregation, we were able to implement the click-to rate and the add-to-cart rate formula. Click-to rate calculated by dividing the number of click by the number of impression, add-to-cart rate calculated by dividing the number of add-to-cart by the number of click. So this table is very useful to evaluate each model on common metrics and to easily compare them. Then a Kibana dashboard is a collection of visualization that you can arrange, resize, and edit. Makes it easier for users to understand and analyze complex information. So in this case, we created two visualizations for the general evaluation of the model. The first one select only interaction with the desktop device, while the other one select only the interaction with the mobile device. We then arrange them side by side in a unique dashboard so that we can quickly get a comprehensive view of the data and make it easier to evaluate the performance of model on different devices. Of course, each Kibana dashboard is customizable in terms of the look and in terms of the information that you want to show. Another interesting application of this visualization type is to evaluate the model performance on a specific product, a specific document. For example, it is useful for seeing how the model behavior on a product of interest that can be a bestseller, a new product, the most reviewed product, a product that is on sale, etc. So this configuration, the configuration of this visualization table is exactly the same as in the general evaluation model, but the only difference in this case is in the data filtering. So using the panel filter, you can create the table using only the interaction related to a specific product. In this case, book ID 9. This visualization can also be used to assess the performance of a model on specific query. So in this case, we have calculated multiple metrics, the same we have seen before, for each query and for a specific model. In this case, we filter by model A. We are only interested in the top 5 queries in terms of total number of interactions that a query collected. So we sorted the rows based on a query frequency, and we only display the first 5 rows. So this visualization allows us to determine which query user interacts with the most and to easily compare them on specific metrics. Finally, the most complex visualization type we use is Vega. This editor allows users to create highly customized and interactive visualization. You can write Elasticsearch query manually using the query domain-specific language and manipulate the obtained response. So you can manage the result and decide how to plot them. We use Vega for evaluating the performance of models on query group according to the search demand curve. So this visualization defines a bar chart to show the average add to cart rate for a specific group of query, in this case 6, with a total impression count of 180 or less. We were able to include several layer elements in the chart with the code in the right, such as this red line for the average add to cart rate. So we calculate the mean of the add to cart rate of these 6 selected query. Then we have a red text that represents the average add to cart rate value, and the blue text for the number of unique query ID. Because now it's easy to see that there are 6 query, so only 6 bar. But if you have, for example, 100 bar, the display of the value is more immediate. Why is it useful to filter on query frequency? Because in general, we expect less queries with a lot of interactions and more query with less interaction. So we decided to filter them on their frequency because it might be more interesting to focus on the model performance of the most frequent queries. And this analysis might help to consider, for example, alternative approaches, such as using multiple models, one model for frequent query and another model for less frequent query. How to filter on query frequency? In this case, we use a bucket selector in the Elasticsearch query to filter and include only the query with a total impression count of 180 or less, and also a click count greater than or equal the add to cart count. This is to remove invalid interactions because in general we don't expect more add to cart action than click on a single query. You can also decide to create a similar visualization but applying a different filter. So in this case, we want to assess the performance of model on queries grouped by the number of search result return, so on query hits. In this case, no need to use the bucket selector, but the filter was applied using the add filter pop-up to exclude documents where query result count is greater than 10. And we obtain these 3 queries, and we calculate the add to cart rate only on this query. Why is it useful to filter on query hits? Because it might be more interesting to focus on the model performance of query with a large number of results. Because, for example, with a low number of results, such as 1 or 3, we expect that the difference between ranking models to be almost absent or neglectable. Okay, finally, again, you can decide to create a dashboard arranging together several single visualizations. In this case, this dashboard displays 6 visualizations side by side. And in particular, the first row is only dedicated to visualization related to the model A. The second row is dedicated to those related to the model B. Then we have the visualization on the left, showcase the average add to cart rate for query with less than or equal 10 query hits. The visualization on the center display the average add to cart rate for queries with query hits between 10 and 50. And the visualization of the right present the average AutoGuard rate with queries with query hits higher than 50. So again, the dashboard is incredibly valuable as it provides a comprehensive view of the data, making it easier to assess the performance of both models and easily compare the AutoGuard rate across different range of the query result count. If you are curious, you can find the link to our blog post about search quality evaluation in general. And we also wrote 3 blog posts related to this talk, where you can find all the details of the implementation with related code, because with a talk of 20 minutes, we were able to only give you an overview of our work. This blog post will be published in a few days, so keep an eye on our blog page. But if you want to stay up to date, I suggest you to subscribe to our information retrieval newsletter. And if you have any question about this talk, feel free to contact us directly. Thank you very much for your attention.